Gen Chem 1. So we're going to talk about the experiment 3A that you have completed at this point and how you can use experiment 3B to assist you in doing the calculations. So in your laboratory manual, if you look at the end of 3A, you're going to see the list of everything you need to include in the lab report for this experiment. And it's quite a bit, so I wouldn't wait till the last minute to get started on it, but I'm on page 52 of the spring 2025 version of the lab manual, and we can see we need a cover page. Your procedure section should be very, very short, and essentially it's just going to be this little section that says as per lab instruction, unless of course you had something in there that didn't go as expected, in which case you would explain what happened and how that's going to affect your results, okay? But generally, that's a very short section. So we would put headings for procedure and then just write as per lab instruction if nothing went off the rails for your experiment. And then your data section, you're going to generate this in Excel if you follow the procedure 3B. It's going to include two different data tables. One of them is the temperatures you measured, and the other one is going to be the masses you measured. You can just copy and paste those right from Excel into your document after your procedure section. You would put a heading that says data, so I know that that's what it is. But just essentially everything you measured in lab gets put into two tables in the data section. You wouldn't put anything you didn't measure in lab in that section, okay? So none of the rest of the numbers that you're going to work on in experiment 3B go there, okay? Graphing is essentially all of experiment 3B walks you through how to do this. So it's important to read the parameters here and look at the example graph, because you're going to generate graphs with the same characteristics that I'm showing you here. The characteristics that I grade on are outlined in this paragraph, okay? So if you're missing any of the components like a title or an axis label, or you don't have the correct precision in your grid lines, or you forgot the unknown, or your range is gonna, doesn't focus on just where you have data, so you have a lot of white space in your graph. Those are the things that you can get marked off for. So you want to be careful to follow the instructions in 3B to make sure you end up with graphic graphs that look similar to this, not identical, can be different colors and fonts and things like that. And of course the data will be different, so these numbers are different than what you have. But the principle of how a graph should look is pretty similar. So if you go to experiment 3B in your lab manual, which is following 3A, it will walk you through this part, and I needed to let you know that there was an edit to the experiment here. The digital version of this document on Google has taken this line out. It is not done in lab anymore. This is something you are going to do at home. But you walk through experiment 3B and you'll get the graphs that you need. If you need help, you can always come to office hours, okay? So 3B walks you through your first temperature graph and the graph for part 2, and then you will use those principles to make the third graph of Celsius versus Mohawk, okay? So the calculations that are shown in this list for part 2 are all done in Excel if you follow experiment 3B. For part 1, you want to do some of these are in the experiment 3B Excel instructions, such as making a temperature conversion from Mohawk to millimeters, and then you make your own graph of Mohawk to Celsius using the same rules. Wherever it says to convert something, so in this case that's going to be there, you're using the equation from the graph, but replacing x and y with the variables from the axes you made. Do that same thing for this point, and then here where it says convert, that's something you need to do on paper. So you're going to take the equations and plug in your millimeters value and solve for Mohawk up here, and then do the same thing where you take the new Mohawk you just calculated and solve for Celsius, and then you're going to compare the Celsius you measured to the calculated value you just did. So these are going to be on paper. Everything else about part 1 is done on Excel, okay? So then for part 2, this breaks it apart very simply for you. You're going to do these things in the spreadsheet if you follow experiment 3B, on paper rather, by hand. You're going to show how you did an interpolation of 19.8%, and you also want to show calculating the percentage of your unknown on the paper. So you're going to go from the density that you measured of your unknown to percent using the equation of the graph. That needs to be written down by hand. Okay. Other than that, everything else in part 2 is also done in the spreadsheet program, right in Excel. Then you copy and paste your tables from Excel that have, for part 2, that have all the answers that you calculated. Okay, so the formulas in Excel are the calculations for most of part 2, but the answers to each of those formulas are going to go in your results section. So you can, as long as you have shown the borders around each cell, you can just copy and paste and put it right into your document as your results section for part 2. For part 1, you do have to create some new results tables. So you want to create an equation list, basically, in a table that lists all the equations that you've generated from your graphs. And you want to have a table of all the calculated temperatures. Okay, and that's going to be created directly in your document. Okay, everything else comes from the Excel file that you're building. And then finally, in your report, you'll answer these questions. You don't need to retype the questions. Okay, your Excel file as well as your document get uploaded for plagiarism checking. So make sure you do that before you come to lab. But you're going to turn everything in physically because it includes all the graphs, all of the narrative portion of your report, as well as the handwritten calculations. So I'm actually grading the physical pages, but you have to submit the digital pages for plagiarism checking. So starting on page 57 is where you're going to find that experiment 3B. This has all the instructions on how to use Excel and the expectations that we have specifically for this experiment. So you kind of want to do this at home as like a mini experiment yourself. If you want help, come to my office hours and I can definitely help you with it. Okay. One of the things you have to do is called interpolation. So it mentions that you, on paper, need to have interpolation of the 19.8% value. In order to do that, we're gonna use an example. I'll show you how to calculate, how to interpolate for the 6.6%, and it's going to be based on the data at the end of experiment 3 on page 64. You're going to need all these numbers. So, for example, when you fill in specific gravity of the saturated solution, that's a 26% solution, you can just copy down this number, 1.1994, right into your Excel file because the 26% is specifically listed here. But we had a 6.6% solution, and that's not specifically listed in the data table, so we have to find a value between two things that are given. That's called interpolation. It's kind of the opposite of extrapolation. Extrapolation would be if we are trying to calculate a density outside of this data set. Interpolation is between two pieces of data. So we're going to interpolate for the 6.6% together, And then you will do the same thing for the 19.8% on the handwritten part of your calculations. Okay, so let me show you how to do 6.6%. What we're trying to calculate is the 6.6% solution. We're trying to find the specific gravity. Okay, so in the lab manual, we have a couple of facts. Okay, so the first one was that the 6% solution has a specific gravity of 1.0432. And the second is that the 7% solution has a specific gravity of 1.055. So that's right out of your lab manual. That data is provided from a giant book of facts, and I just collected it together for you. So if we're trying to get 6.6 because it's between the two numbers that we have, so that's called interpolation. So you could do this with a graph if you wanted to. So if I graphed 6% and 7% on the x-axis, right, the horizontal one, the y-axis would be 1.0432, and that data point would intersect right there, and 1.0505, and so it would intersect there. So as concentration increases, density increases, is what we just learned. And so what we're trying to do here with an interpolation is find out what it would be at 6.6%. So I'm looking to figure out what is the specific gravity right about there. So again, you could do this graphically. I think sometimes we also need to be able to figure this out without having to pull out a graphing software or a piece of graph paper. And so the process is essentially to calculate the slope and use that to figure out the difference between where we start right here and where we're going. Okay, so first off, to calculate a slope, it's the change in y over the change in x, right? So here it's going to be 1.0505 minus 1.0432. You could have assigned the y and x the other way around. There's no rule that says I have to do specific gravity on the y. I just happen to know that that's going to make the math a little easier to understand, so I chose to do it that way. And then I'm going to go, in this case, the larger number minus the smaller number just to keep things positive. I don't have to, though. But what I do have to do is make sure whichever order I select my y values to go in, I need the x values to match. So the x value that matches 1.0505 is 7. So that one goes first. And then 6. Okay. So effectively, you just need to make sure that these are paired up correctly in order to calculate the slope. So the answer to that calculation is 0.0073. In other words, that's the slope of the line. If I were going to graph it, that's what I would get. Okay. In order to figure out what the value is for 6.6%, we need to figure out this gap right here between where I'm starting, 6%, and where I'm ending. So this gap in the x-axis for this example is 0.6, okay? I'm going to take the slope that I just calculated and multiply it by that gap. Don't do anything with the percentage, okay? It's just a unit. We're not going to get rid of it by dividing by 100. Just leave it there. So this comes out to be 0.00438. And what that tells us is how big the black line is here between my starting specific gravity and the one I'm searching for. That's an increase because the specific gravity was going up as the percentage goes up. So I'll numerically just add that together, right? So I'll take 1.0432, where we started at 6%, and I'm going to add in the answer I just figured out. And that's going to give us the value we're looking for. It says 1.04758. Now, just to double check our significant digits here, which we want to match our data. So we had 5 significant figures, 4 decimal places, but 5 significant figures. And so my very final answer for 6.6% is going to be 1.0475, but I've got a round, okay, because the next digit is bigger than 5. So we would round to 1.0476. And that's what you can type into the Excel file under specific gravity for your 6.6% solution. You can use the same mathematical process with the 19.8% solution, and you'll be able to finish all of the other solutions just by looking directly on the chart at the end of the experiment. Hope this helps, but as always, if you have questions, come see me.